complex numbers, the basics. The imaginary unit, and some of y'all may remember this, it's that lowercase I, and it represents the square root of -1. Now with real numbers, you can't have a square root of a negative. So the imaginary numbers are actually a larger set of numbers that encompass the real numbers, but they have also this imaginary unit. Okay? So the imaginary unit is I, and it equals the square root of -1. So what do you think happens if you square I? You get I squared. Well, if you square the square root of -1, you get -1. So I squared is -1. And then I to the third. Now, how do I get negative I, you suppose? Well, I to the third is I squared, which is -1 times I, right? And then -1 times I is just -I. So that's where that comes from. I cubed is -I. And then I to the fourth is 1 is what? Well, look, isn't I to the fourth I squared times I squared? Well, I squared is -1. What is -1 times -1? It's +1. So that's where I to the fourth equals 1 comes from. And then I to the fifth I have as I. Well, wait, that's I to the fourth times I, but I to the fourth is 1, right? So 1 times I is just what? I. So what you'll notice here is the powers of I are repetitive. Every fourth power of I is the same. So I to the third is the same as I to the seventh. That's 4 later. Same as I to the 11th. Same as I to the 15th. And that's -I. Simplifies to -I. I to the 8th is the same as I to the 12th. It's the same as I to the 16th, 20th, 24th. They all become 1. Okay? So here's the thing about this imaginary unit and these complex numbers, okay? Imaginary numbers. In the real world, I took a class in grad school many years ago called Complex Analysis, all right? There's a movie called Good Will Hunting, and where Matt Damon is a janitor, and he's at an Ivy League school, and the professor puts this really hard problem up there, and nobody in the class can solve it, and while he's mopping the floor at night, he goes over and just solves it, and the professor comes in and says, Who did it, right? That was something called Fourier Analysis, and Fourier Analysis is in complex analysis, okay? It's actually real-world application of complex numbers, which kind of sounds funny, or imaginary numbers in the real world. Also, in that class, I had some engineers. So that tells me that engineers, when they build a bridge or a building, or when they do some calculations for something that they're doing, they might very well use complex numbers, okay? So complex numbers are complex or imaginary, but they are useful in the real world. All right. So then complex numbers have a standard form. It's A plus BI. A is the real part and B is the imaginary part. The thing times the I is the imaginary part. So the A is the real part. So if B equals 0, okay, if B is not equal to 0, then you have an imaginary number, right? That means you have some imaginary part there, okay? So if A equals 0, it's called a pure imaginary number, all right? And then the complex conjugate. So you may have heard of conjugate, and I'm not talking about conjugate a verb or whatever in the language, but a conjugate in math is A plus BI and A minus BI. Notice we just changed that one sign there before the I term, basically the radical, okay? Because I is the square root of -1. So, and because we talk about it being a radical, right, we'll do some more things when we do some calculations here in just a minute, okay? So A plus BI, A minus BI are complex conjugates. So what I want to do is work a few problems here involving imaginary numbers. And even if you didn't know what was going on here, if you just saw this problem right here and said add, you would say, oh, I bet I know what I do. The parentheses here, I can just drop them, -2 plus 6i, and then I have 4 and I. Let's see, and a plus means don't change them, so it's going to be +4 and -i. Well, and if I line them up, you may even do them vertical, horizontal, whatever. -2 plus 4 is 2. And then plus 6i minus I is plus 5i. So there's 2 plus 5i. Boom, 2 plus 5i. It's done. All right, and you would probably get that one right. The next one you'd probably get right too without even knowing what I was. So here you'd say, okay, -7 plus 5i, but wait a minute, I'm distributing a negative, and all that means is change the sign. So I have a 9 and an 11i. They're both negative, but the negative out front says change them, so now they're both what? Pluses. -7 plus 9 is 2, plus 5i plus 11i is plus 16i. So 2 plus 16i is that one. The next one you do need to know what I is because you're going to FOIL, right? You have 2 terms times 2 terms. So, over here we had a minus sign between them and a plus sign. That told me that I added and subtracted, right? So then here, what's between the two parentheses? Nothing. If nothing is between something in math, it typically means multiply. So we're going to multiply these. First, outer, inner, last, FOIL. Okay? 7 times negative 2 is negative 14. Then we have 7 times negative 3i is negative 21i. Then we have negative 5i times negative 2 is plus 10i. And then we have negative 5i times negative 3i. So a negative times a negative is positive. 5 times 3 is 15. And I times I is I squared. Okay? So I look at this. I go, okay, wait a minute. Let's see what I can do. Well, those two terms go together for sure. So I get negative 14 and I get minus 11i. But wait a minute. I squared is what? Negative 1. So up here I'm going to think about this in a thought cloud. Okay? It's going to be plus 15 times what? Negative 1. Well, what is plus 15 times negative 1? It's really minus 15, isn't it? And then I'm going to take this and put it together, and I'm going to get negative 29 minus 11i. So all of my answers here, I'm going to write in standard form. I didn't give you directions here, but I'm going to do that because many, many books, many teachers, many professors, many instructors, many software packages, when they get to complex numbers, they put it in standard form, okay? Not necessarily you have to unless they tell you to, but it's sort of the accepted practice, I suppose. So I'm going to put my answers in that here, even though I didn't tell you to, but I want you to see that, so that way if you have to do such a thing for your class, then you will be prepared, I hope. All right? So then the next one, 5i over 2 minus i. Well, 2 minus i in the denominator is like having a radical, and you know, we're taught we have to rationalize the denominator, which is actually not true. There's no mathematical purpose to do that. I've had several elder statesmen in the math world tell me, multiple, one was an engineer, one was a math professor, one was another math professor, who've told me, hey, the whole reason we do this is because of slide rules and tables of values and things like that back in the day, and not having to divide with those lots of decimals. And that's why we did it. It's why we rationalized it. And then it just became the accepted rule or practice. So there's actually a time in math where rationalizing the numerator is much more important and is necessary. Okay? Just a few weeks into Calculus 1. First semester calculus, you have to do it to solve something or to finish a problem. So, but never in my life have I ever seen a problem. And I've been, tutoring or teaching math for 32 years. I've never in my life seen a problem where absolutely mathematically had to rationalize the denominator. But we're going to do it. We're going to do it. All right. So here we have 5i over 2 minus i. We're going to multiply this by the conjugate, 2 plus I over 2 plus I. So when you do that, the conjugate, and you do this with radicals, okay, so we're doing the same thing. We're just doing the complex conjugate. So when we do this, we're going to distribute the 5 here. That's going to give me over here 10i plus 5i squared over, now this is going to be first, outer, inner, last, okay? 2 times 2 is 4, and I'm going to write this down, plus 2i, but then you have minus 2i, don't you? And then you have minus I squared. So plus 2i minus 2i cancels. Let me fix that. That looks awful. That's like 20. Nope, not that one. I want this one. Nope, I don't want that. I want this. I don't. That's what I want. Okay? That's what I want. So let me erase that there. And then, how bad did I move that? Did I move that real bad? Not too bad. All right, so then put the I back in here. So the plus 2i minus 2i cancels. Then we come back and say, oh, by the way, this was what? Negative 1. So we have 10i plus 5. Oh, and this is also negative 1, is it not? So that's really not plus 5. It's what? Because it's like, this is negative 1, so it's like 5 times negative 1. So it's minus 5 over 4 minus a negative 1 is plus 1. Remember, right here, I'm thinking about minus a negative 1. And up here, I'm thinking about what? 5 times negative 1 with a plus in front of it. Right? So, didn't make that thought cloud big enough. Let me do that a little bit bigger. Plus 5 times negative 1 in this thought cloud. Okay? So that's right. That's where the negative 5 comes from. This is where the negative 1 comes from. Okay? So, then I come back and go, okay, wait a minute. Hang on a second. Hang on a cotton picking minute, right? I really need this to be, let's see, well, I'm just going to go 10i minus 5 over 5. But then I say, look, it needs to be in standard form, so I'm going to put negative 5 over 5 plus 10I over 5. That's supposed to be an I. Those become a 1. That becomes a 2. So this is going to be negative 1 plus 2I. Negative 1 plus 2I. So that's just a better way to write 5I over 2 minus I. I would much rather have that. So here, there's a good use for this with i's, but not necessarily the radical itself, just it's the imaginary part that makes it easier to do this way. Again, not a necessary thing, not a have to. It just makes it easier to deal with. All right, negative square root of 81 minus negative, or squared, I'm sorry. I said that wrong. Square root of negative 81 minus the square root of negative 144. The square root of 81 is 9, and the square root of negative is I, right? This negative is this I, this is 81, right? It's 9. And then minus, that minus sign comes down. It doesn't, you can't distribute that there. That can't work. No. So then inside the radical, the I comes from the negative, and the 144 gives you what? 12. So you get 9I minus 12I, and that gives you negative 3I. All right, because those are like terms. And that's what we call a pure imaginary number. The A is 0. There's no real part to that. And then lastly here, negative 12. We're going to break this up into negative 4 times 7 under the square root. Okay, and then I can take the square root of negative 4. So I'm going to have negative 12 plus 2I square root of 7. Where did the 2I come from? Square root of negative 4, right? Square root of 4 is 2. The negative is the I. So that's what I did there. I just, instead of rewriting the whole thing, I just took this radical and rewrote it right here beside it. Okay? Saved myself a step. So then I'm going to break this up and say negative 12 over 32 plus 2 square root of 7 over 32I. And the reason I did that is, again, A plus BI, right? So I'm putting my fraction in front of it and my I out there. If you write slanted fractions here, don't. You're going to do it wrong unless you use parentheses. And if you use it wrong, I'm going to count off if it's my test. Okay? So what I mean is if you did this, then what you just did was put 32I in the denominator. If you put it in parentheses, you're okay, but nobody does that. So the best thing I can say about slanted fractions is if you write them, don't ever again. Okay? And if you're a teacher watching this and you use slanted fractions, look, you and I, as the teacher, we know when it's okay and when it's not. We know how to do it properly. The problem is we're teaching students who are trying to learn, and when we do slanted fractions, that's something that seems very ambiguous because sometimes it's okay and sometimes it's not, and sometimes it means this and you don't use this. And all. Just don't do it. Just don't do it. So I never will do it. Never. I don't even do it when I'm writing something. All right? I'm so against it. All right? But it's okay when it's okay. But again, when you're teaching students who are trying to learn, So students, you take my class, I'm not doing it. Never will I write a slanted fraction, ever. So if you do, my advice to you is just don't. All right? So then, not being ugly, just trying to help it make more sense for you. So then 4 goes into both these. 4 goes into 12 3 times, and 32, 8. So this becomes negative 3/8. Then plus 2 one time, and 16 times it goes into 32, right? So this is the square root of 7 over 16, and then I. And the other thing is, when you write square root of 7 over 16I, don't put it down here, because then if you extended it out, it looks like it's in the bottom. So it can be up top with this one, up in that level. But to write it in standard form, technically it's supposed to be out beside it. So I write it where the fraction line would cut it in half if it was extended out, okay? So because then there's no ambiguity whatsoever. You know that I is not part of the denominator at the bottom, okay? So hope this helps out with complex numbers. This was just a few basic problems with some operations with them. So again, hope it helps. Good luck in your math class.